peninsula sticking up. Sometimes it's just a little tiny mound, okay? Other times it really sticks up like a peninsula. When you look at it, you should be able to make out lighter staining hair cells, at least partially in there. There's more in here that are staining a little bit light, but some won't really pick up a light stain. You can kind of get the idea there's hairs right here, and then you may not see any cupula, you may see a little piece of it. You're never gonna see it looking like that long symmetrical dunce cap that we had in the drawing, okay? It's glycoprotein, it gets removed during fixation to a great extent, and you're lucky if you have a remnant of it left. Okay, didn't have a whole lot of slides to choose from. I would normally have ignored this, would have moved on to another site. Very poorly stained, but once again, you can see that little peninsula of tissue sticking up, and then you can't make out the lighter colored cells, but you can tell that cells change. You know, right at this point, they change from what's below and what's above. Stays changed until you get right here, and then it changes back to that basal layer. And you get a little bit of an idea of that cupula on top. Okay? Crista ampularis detects angular acceleration. All right. Here we see one shows a nice peninsula sticking up. You can see once again, if you can't make out the hair cells, you can at least make out there's a change in the surface cells in there. They epithelium, but once again, there's nervous tissue components in there. You can see the layer here where the hairs are, and what was a cupula that normally came up, you know, let's say came from like right here and came up, you know, came down, back over like this, is left to this little tiny piece right there. Okay, cupula is going to be distorted. If you have any of it left, it's going to be distorted from what it looked like originally. All right, here is one that's more of a mound, isn't it? So that was where peninsula really sticking up. This one was more like a mound. Question. The whole structure, whoops, the whole structure is a crista ampularis. Yeah, all these features would be where the hair cells are, the hairs, the cupula, just features of the crista ampularis. And that this hollow right here is the semicircular canal. Okay, the fluid that is, you know, that's going in a circle now is passing over this and bending the cupula, bends the hair cells. Okay, sometimes a crista ampularis looks like this, and I don't know if this is maybe a slightly different location. They're all at the base of the, there's multiple of these at the base of each semicircular canal. I don't know if this is a difference in terms of where it is. I don't know if it's a difference in terms of species. I don't know if it's a difference in terms of a person that, you know, doesn't have a great sense of equilibrium. Don't know the answer to that. I just know you see it where it looks different. And indeed, you're used to seeing it projecting up, you know, as a large peninsula. Here it's that little mound, isn't it? Okay. Look at it though; it's got all of the same features. If you look at the epithelial lining, all of a sudden it changes right here once we start getting those hair cells involved. I can see some neurons back here even. I didn't go into, but you can see that cupula was maintained a little bit better here than it has been on the previous slides. Once again, that cupula would have extended all the way from here, you know, come up and stuck way out into that opening of that semicircular canal, and then come back down over on the far side to here. Whichever you see a cupula, you're only seeing a little tiny remnant of it if you see it at all. You know, it's a shame you buy these very expensive slides and none of them have cupula on them. Okay, that's the name of the game a lot of times. All right, and I guess I did the these sites for each of the structures here. Once again, all of these should be active still, as far as I know, and that brings